So I'm back with more silly RGB tricks that you can do with your spare Lighting Node Pros. Today, I'm going to take a look at controlling 12 volt addressable RGB LEDs from a Lighting Node Pro. Now, to make it clear, I'm not talking about controlling the 12 volt analog RGB strips like you can do with Solarity's RGB DAC. No. What I'm talking about is actually controlling addressable 12 volt LEDs. Now, these are WS2815 addressable RGB LEDs, and we're going to look at controlling these with the Lighting Node Pro. Now, I found these Alatov, however you pronounce it, LEDs on Amazon, and they're marketed as upgraded WS2812Bs. So I figured I'd give them a try. Well, it turns out that I wasn't the first one to do this. I had a great discussion on Reddit with Introvert Motown 1 about this, and it turns out that they had done a write-up some time ago that I hadn't seen. They've also done a lot of other pretty cool stuff with Lighting Node Pros that you should check out too. I'll have some links below to some of the Reddit posts. Now, back to these LEDs. First, they call them upgraded. Well, how are they upgraded? Two ways. Of course, rather than 5 volt, they're 12 volt. That kind of came with the package. Now, according to the listing, though, with 16.4 feet or 5 meters, there won't be any voltage drop. Now, this is significantly different from what we see with the 5 volt LEDs, so we shouldn't have to inject power after a long strip. They also claim to be ultra bright as well, whatever that means. So we'll see. Second, and this is pretty cool, they have two data input channels. One of them is data in, and one of them is data backup. So this is supposed to allow the rest of the series to continue lighting up even when a single LED dies. This is a big problem with the WS2812Bs. And it looks like these are upgraded to get around that problem. So let's take a look and see how we can do this. I've got my trusty multimeter here so we can measure how much power is actually used by these LEDs. So we've got, I think, 5 meters right here, 300 LEDs. Now, the packaging claims that it's going to use 14.4 watts per meter. So that's going to be about 1.2 amps for 60 LEDs. We'll see if that's the case. So let's go ahead and get to it. All right, so let's start with how we have all this hooked up. So I've got this GeekPi Team ATX 20-pin adapter connected to an SF450 power supply. I could not find a 12-volt DC power supply to do this. So this is what we have rigged up. It will work because we can get the 12-volt power right from the power supply. We can also get 5-volt power, which we need for the Lighting Node Pro, also right from the power supply. So this works actually quite well. I use this for a bunch of different things because it's just handy dandy. Coming out of 12 volt, we have bare cable here. This is what we are going to hook the multimeter up to. So that way we can measure the voltage. And, well, not the voltage, but the amperage that it actually uses, right? So we're going to hook this up. And here we go. And so, in this end right here is connected to the, is going to be connected to the power for the LEDs. So power on the LEDs is going to be red, black, of course. This right here is black, is going to be ground. These two cables right here are data in and backup data. So those are those two data lines that I was talking about. That is what we are going to put the signal or provide signal from the Lighting Node Pro. Now, to provide signal from the Lighting Node Pro, I have this hacked cable that I put together from a Pirate Dog hub splitter. So what I'm doing is right here, this is pin 2. This is going to be the data out from the Lighting Node Pro. I'm splitting that into pin 1 and pin 2 on the 3-pin Molex. And then the ground, I'm just doing a single ground. That's going to also be connected to pin 3 for ground. So over here, you'll see that I have pin 1 and pin 2 for data in and data backup, and then pin 3 for ground, because we do need to have the signal connected to ground in order for it to work. So we'll connect this right here, and then we will connect this to port 1 on the Lighting Node Pro. Now for it to get power, I have this cable connected to the 5-volt coming out of the motherboard. So this will give us the power. Now with these connectors, we can only do 3 amps, but we really aren't going to need a whole lot of power because we're not going to be driving any power from this Lighting Node Pro. So of course, connected to USB. You might have heard it connect. So there we go. We have, let's go ahead and turn this on so that way we can see what our power usage is. All right, so we're down at 0. I'm going to go ahead and connect the, alrighty. Okay, so we've got everything connected. We can see the Lighting Node Pro in iCUE because it's connected via USB, even though it's not getting any power just yet. We can go ahead and get it configured though, make sure that it's ready for us to turn things on. So we've got lighting channel 1 set up for 6 RGB LED strips. So that will give us 1 meter. So we'll see if that hits the 14.4 watts per meter. On lighting channel 1, we've got it set up so that all 6 are at full white. So this will give us the maximum amount of power that it will draw when these things are lit up. So I'm going to go ahead and turn on the power supply. So I'll hit the switch. So we see the power supply is on. Everything came up. The LEDs are lit up. They are really bright. I can't really measure it specifically, but just from eyeball, I would say they're a good deal brighter than the typical 5-volt LEDs. You can also see at 1 meter with 60 LEDs, we're pulling at about 0.57 amps. So that's going to be a little over 6 watts. So that's actually probably about less than half of what they're spec'd on the label, which is kind of interesting. But that also means that we can certainly power a whole bunch of these things from a single Lighting Node Pro, or even really a single adapter, right? Because this would be 60 of these with the standard 5-volt Corsair strips would be almost 2 amps. So that would be about 10 watts. So significantly less power is being drawn, and these things look a whole lot brighter. Now let's go ahead and turn off the all white because that is so bright. Let's go ahead and turn on watercolor spectrum. And again, it's so bright, it's probably hard to see in there, but we can definitely tell that, yep, it is absolutely controlling these. We've got watercolor spectrum in 12 volt. It is really bright, really bright. Let's come into the lighting setup and let's see what we can do here. Let's just crank this up a bit and we'll do there we go, the external RGB strips. Let's take those out. Let's put in one of these. Let's put in the 2 450 millimeter. So these are 138, and I mean it is cranking them. It doesn't look like there is any reduction in brightness at all throughout all of the LEDs on here. Yeah, it's incredibly bright on the screen. So let's see what happens. Let's see how much power we get with these at all white. So with watercolor spectrum, we're looking at about 1.23 amps. So at all white, let's turn that on. There we go. At all white, we're still looking at about 1.2 amps. Really? Yeah. Let's turn that off. Yeah. So and these are all white, so it doesn't seem to matter much from watercolor spectrum. We go down to almost nothing there. So this is still at 1.2 amps, regardless of what we do. So that's kind of different, because with the with the 5 volt, we certainly see reduction in power as it goes through different lighting. And so here, so this is interesting. Going on full rainbow, we actually, wow, we're all over the place, right? But it's going up to almost, looks like it hitting almost 1.3. Let's hit the max. So a max of looks like 1.2, 1.26 amps. So that's kind of interesting in that it is drawing more power with it as rainbow than it would with it as, say, watercolor spectrum or full white. So let's do rainbow wave, which is a little bit different. And then, yeah, and we're still not getting max over there. This looks like rainbow wave is actually even less. So we're down around about 1.2 amps of 12 volt power. So that power usage is really is pretty low, which means we won't have to get massive power supplies or inverters to actually power this thing. So let's go ahead, and I want to take a measurement of the voltage drop at the end of the chain. So here we go. So this is, let's see if we can, let's get this other one in here. There we go. So we see this is going to be measuring voltage. So let's go here. So this would be 12 volt. And we can see we've got a little bit of voltage drop. We've got that's at 11.3 volts, but that's after 138 LEDs. So that is actually really small voltage drop throughout a pretty long strip of LEDs. So there we go, a bit jury-rigged, but we've certainly proven the concept that we can control WS2815 LEDs from a Lighting Node Pro. Now, surprisingly, the power usage was lower than advertised. 1 meter came in to around 6.7 watts, and 138 LEDs, which is a little bit over 2 meters, came in at only around 15 watts. So was that a typo in the packaging? Not really sure, because it seemed to come in at about half of what they promised. Not that that's a bad thing. I'm certainly not going to complain. Now, this also means that the power load for a fully loaded SP901E that we've played with before, with all 8 channels, would probably be in around the 10 amp or 120 watt range. Now, 12 volt DC adapters that can handle this are really easy to find on Amazon for 20 bucks or sometimes even less. And you can use 18 to 20 gauge wire to handle it. So it'd be pretty easy to wire up. You throw in a small buck converter. You wouldn't need a whole lot of 5 volt power if you're not powering any LEDs from the Lighting Node Pro. And you'll have an all-in-one controller for 12 volt LEDs using a Lighting Node Pro. If you want to get even crazier, there's no reason why you can't add a second SP901E into the mix and give that one 5-volt LEDs, because the SP901E will supply whatever voltage you supply to it, to the LEDs. So you could actually have a mixed 12-volt, 5-volt LED setup that's all controlled from a single Lighting Node Pro. You can get pretty crazy with it. Last, this also further supports my hypothesis that the Link fans are using these same WS2815 LEDs. We saw before that they are 12-volt LEDs inside of the Link fans. We saw that they had 4 connections, just like the WS2815s. And now that we've shown that they can be controlled just like a Lighting Node Pro, so that protocol being something that Corsair is very familiar with, they've been using it for a long time. It really makes sense for them to just do those as WS2815s. So with that, that's all I have for now. I'm probably going to be doing some more with this. I'm going to rig up a whole bunch of stuff and actually kind of do it right. But that might be something for later. And if you like this video, go ahead and give it a like down below. If you want to see more RGB stuff and other random stuff that I may do, go ahead and hit subscribe. Would really appreciate it. So until next time, may your RGBs be bright and your temps be low, and I'll see you then.